Good morning, students. I hope you are all doing well. Great. Today, what we are going to discuss is about the prime numbers and composite numbers. Then you move on to the prime factors. We are going to learn something about the prime numbers and composite numbers. You make sure that you find the difference between the prime number and the composite numbers. Things that will help us to identify the prime numbers and composite numbers. Our previous lesson, we did discuss something about the factors of numbers. And we said factors are numbers that can divide a given number exactly, or factors are numbers that can divide a given number equally. Now, based on our previous lesson, or based on the factors, we are going to use the same definition to find or identify the prime numbers. Once you know your factors, you should be able to also know your prime numbers. So, if you are here and this is your first time of listening to this video, please find the factors or the lesson of factors, and then we come back to this side. Once again, we said factors are numbers that can divide a given number equally, and we also did some calculations how to find the factors of a given numbers. We listed 1 to 10, and then you find the numbers. When you multiply by that 1 to 10, that will give you the given number. So based on that, you should be able to find all the factors of the given numbers. You have no other option to tell us that the factors, you have listed some and then you left the remaining. So once you know your factors well, you should be able to identify the prime number or a composite number, or even the prime factors. The word prime factors here means factors of the numbers which are prime numbers. Okay? When you list the factors of a given number, then through the list of the given number, you should be able to identify the prime numbers. That is exactly what you're going to do today. We also said that the factors, it has three features or three characteristics that will enable you to identify the group of numbers belonging to a certain number, okay, or a group of numbers that can divide a given number equally. One, we said one is a factor of every what? Number. One can divide every number equal. That is why one is a factor of every number. We also said the second feature of factors is every number is a factor of itself. So once you want to list the factors of numbers, first thing you have to do is that one can divide every number equally, and the number itself can also divide itself equally. That is why every number is a factor of itself. And then the last bullet, that is factors, it has definite end. Factors, it has a limitation. It means factors, it has a limit number. So the first say, or let's say the factors of a given number doesn't mean so between analysis accuracy. There be it has end. Okay, that is factors, it has definite end. Definite end means it has a limitation. So let's say you have to what store based on the numbers given. So these were the three properties that govern us to identify the factors of numbers. Okay, good. That was last week or the previous lesson that we did discuss, the factors of numbers. But today we are going to learn something about the prime numbers or prime number. what is a prime number? What are the prime numbers? How can you identify prime numbers? It's not difficult, okay? And then you also consider the composite number. What is composite number? What are the composite number? So by the end of this lesson, you should be able to know your prime numbers, your composite numbers, and prime factors. Prime factors means the factors which are prime numbers, the factors of the given number which are prime numbers. Okay, good. So after finding the factors, and then you select the prime numbers. So let's move on. When you talk about the prime numbers here, prime numbers are numbers with exactly two factors. And normally it's one and it's a number. Okay. Per your level, you're supposed to know the prime numbers. This is not advanced topic, but you're supposed to know what a prime number is. Yes, prime number are numbers with exactly two factors. Remember, say we listed the factors of a given numbers in our previous lesson. Boom said those numbers that can divide a given number. Ebi wɔ ha ɔmo dɔɔso, ebi wɔ so ɔmo sa, ebi wɔ ɔmo so ɔmo yɛ bebree, ebi wɔ koraa na ɔmo yɛ 2 pɛ, ebi yɛ 3, ebi yɛ 4. So those numbers na ɛfɛ ɔmo factors. And a prime number no so pɛ sɛ ɔkyerɛ sɛ when you list the factors of a given number, okay, the numbers or the members or the elements in the set or those numbers that can divide the given number is supposed to be 2 pairs. Okay, so if those numbers, it has only 2 members that can divide a given number, then that number is called a prime number. Okay, number ne factors, number ne nkrofo e 2 pair 8 ni divide on nko. The one number do any nipa 2 and our number is 2 pair any bit me divided is aside number 2 number b and in divided those numbers. So if the particular number is having only 2 factors and our 2 factors na ya na 1 and a number 9 and it me divided a particular number. Okay, so it's normally 1 and is can divide a prime number. Your numbers be free, but it be within the prime numbers. A point before so we say number way a prime numbers. Let's see the features or properties of prime number. Niema a bed down so amu who say numbers with a prime numbers. Unless say we don't know your factors. Prime numbers has only 2 factors. It has only 2 factors. One, the only thing I'll be going to say, a particular number to be a prime number. First thing you have to do is that you list the factors or you find the factors of that number. And if there's a conditional sentence here, and if there is only 2 factors or only 2 numbers that can divide that particular number, definitely that number is a prime number. Okay, so numbers beat me a cancel or numbers beat me a divide or 2 numbers when you multiply you get that particular number. There are 2 pair numbers mean pen then that number is a prime number. Okay, another one I'll be to so identify say number be a prime number. The factors of prime numbers are only 1 and is the same. They are the same here. Okay, so the factors of what prime numbers are only 1 and is a number. So prime numbers, almost factors in there, 1 and a number 9. So number be ne factors 1 and number 9. So number no your friend say a prime number. Okay, so you have to learn your factors well. Okay, in catchy. So let's see some of the examples of prime numbers, okay, before you come back to what? The composite numbers, okay? Good. Now, before you work out with the examples of what? The prime numbers, I hope say you know the factors, the factors and finding the prime numbers. So one, you list the factors of any number that you want to identify whether that particular number is a prime number. Then you first find the factors of that, and with that, you check whether the members or the numbers that can divide that particular number are two. Two no so koraa no, hwɛ hu sɛ ɛyɛ one ɛna number na. If say number na ebetumi divide a given number no yɛ 1 and itself, then that number is a prime number. Okay, so let's see the other bullet here or the other slides here. Composite number, but the meaning is very understandable here. When you talk about a composite number, those numbers that are not prime numbers are called composite numbers. So composite numbers are numbers with more than two factors. Okay, so prime numbers are numbers with only two factors there, and normally it's one and itself there. Then what about those numbers are more than two factors, and what's the name given to that? That name is composite number. Okay, so composite numbers are numbers with more than two factors. So some of the factors of numbers, they are more than two. Okay, one is not a prime number, one is not a composite number. One, it has only one factor. Okay, so there's no need to ask the name of one. One, when you find the factors of one, it's only one. One can divide one equal. Aside one, there is no number. Two can never divide one. Three can never. So the factors of one or the factor of one is one. Okay, so one is not a prime number. One is not a composite number. But here, the composite numbers are numbers with more than two factors. Numbers are the factors in the doors two. Okay, if you two air corner numbers are more factors and more than two, or more numbers between divide a given numbers are more than two, then that number is a composite number. Unlike prime numbers, prime number they have exactly two factors. Two pair one and a, but the composite number no, they are more than two. Okay. Features or properties of composite numbers. Composite numbers has more than two factors. Then factors of composite numbers are more than two numbers. So when you count the number of factors of a composite number, they are more than two, unlike prime what? Numbers. Okay, so composite number has more than two factors. Factors of composite numbers are more than two. Okay, good. Then let's see some of the examples here before you come back to this side. Now you are going to find the factors of these numbers, seems 1 to 12, and then with the help of the factors of numbers here, you'll be able to identify those numbers which are prime and those numbers which are composite here. Okay, and remember, say you can say prime numbers are numbers with only two factors, while composite numbers are numbers with more than two factors. So based on this definition, we are going to use it to identify those numbers that belongs to the prime numbers and those numbers that belongs to the composite numbers. Okay, by using the factors method. Okay, you use factors to determine the numbers that belongs to the prime numbers and the numbers that belongs to the composite numbers. So first thing you have to do is that the only thing that you have to do to identify a number is a prime number, you have to list the factors of that number. So all the factors of that number, it will help you to know say number we are well listen based on the factors levels. We a prime number, we see a composite number. Those are prime numbers, you know, you see they have only two factors. A yes so a one and a number na any team divide that particular number. So if factors of a given number is having two factors here, normally it's 1 and itself there, then that particular number is a prime number. Okay, the name of that number is a prime number. It's a prime because it has only two factors. Then the other one, composite number, almost say numbers with more than two factors. So based on our factors here, you will be able to identify that these numbers are composite numbers. So without waste my time, let me find the factors of one. And yeah, how to find factors. So I will not waste my time here. If you don't know how to find the factors, watch our previous lesson on factors and then you'll be able to do that. Okay. So the factors of one, the numbers that can divide one equally, or the numbers that can divide one equally here is only one. Okay. Or the numbers when you multiply you get one. It's only one. So 1 times 1 is 1. And since we have only one, then that is the factors of 1. It has only one factor. Okay, good. So based on this one here, because factors of 1, a 1 penny, on your prime number, on also on your composite number, because a prime number is a number with more than two, or a prime number is a number with exactly two factors, while the composite number is a number with what? More than two factors. Okay, sorry. Then let's see the factors of 2. Factors of 2, one can divide 2 equally and the 2 itself can also divide 2 equally. Okay, good. Factors of 3, one can divide 3 equally, 2 cannot divide 3 equal. Okay, and then 3 itself can also divide 3 equally. Okay, good. Factors of 4, 1 can divide 4 equally, 2 can also divide 4 equally, 3 cannot, but 4 itself can also divide 4 equally. Then factors of 5, 1 can divide 5, 2 cannot, 3 cannot, 4 cannot, 5 itself can divide 5 equally. Okay, I hope you know how to find the factors of numbers. You first list 1 to 10 and then you multiply those numbers. When you multiply by those listed numbers here, that will give you a given number. So I hope when you watch the previous video, you should be able to identify or find all the factors of a given number here. Factors of 6, 1 times 6 will give you 6. 2 times 3 can also give you 6. 3 times 2 can also give you 6. 4 times can never give you 6. 5 times can never give you 6. And then 6 times 1 can also give you 6. Okay, good. Factors of 7. 1 times 7 will give you 7. And 2 cannot, 3 cannot give you 7. 3 times cannot give you 7. 4 times, 5 times, 6 times, 7 times 1 can also give you 7. Okay, so good. Now factors of 8. 1 times 8 will give you 8. 2 times 4 will give you 3 times can never give you 8. 4 times 2 can give you 8. And then 5 cannot, 6 cannot, 7 cannot, but the 8 times 1 can also give you 8. Okay? Then factors of 9. 1 can divide 1 equally, 2 not, 3 can also divide 9 by 3, and then 4 cannot, 5 cannot, 6 cannot. When you use the method, you should be able to identify. That is why I want you to go back and visit the video and watch the practical aspect of how to find the factors of numbers. So I had my work that so over here no had their own tears. It's also up for they are very necessary. So here factors of 9 we have 1, 3, and 9. Let's see the factors of 10. 1 can divide 2, 4 cannot, 5, 6 cannot, 7 cannot divide 10, 8, 9, and then the 10 is okay. Good. Factors of 11. 1 can divide 11. The rest, unless 11 itself, can also divide itself here. Okay. Factors of 12. 1 can divide 12, 2, 3, 4, 6, and then the 12 is okay. Good. So now we have the list of what numbers 1 to 10, 1 to 12 rather here, and then based on the factors of the numbers, and a be who's a number be a prime numbers here. Okay, so let's see examples of prime numbers here. Factors of 1 will help us to identify say whether it's a number or a prime number, but when you check the factors of 1, it has only one factor here, which means that 1 can never be a prime number because a prime number is a number with exactly 2 factors. It has only 2 factors. Normally, so 2 factors, 1 and a number now. Okay, so let's see this one. Okay, factors of 2. Let's check the factors of 2. It has 1 and 2. Let's see the properties of prime numbers here. The factors of prime numbers supposed to have 1 and itself 2 because this is a 2 and itself is also a factor here. Okay, and beside this one is also part of what, or the properties of what factors. So so as a prime number, a number, it has only 2 factors. Now we have 2 factors here, 1 and 2. And what's number no I have a 1 and a number 9. So we have the 1 here and the 2 itself is over here. So the number 2 is a prime number. Okay, let's see factors of 3. Number 3, whether 3 is also a prime number. So factors of 3, we have the 1 and 3 here. Only 1 and 3 can divide 3 equally. Therefore, because they have only exactly 2 factors, it has exactly 2 factors, and the factors in the you pay. And the you no cry a 1 and a number now. So based on this, or based on the definition, or based on the factors of the 3, we can also conclude say 3 here is a prime number. Okay, let's see the factors of 4. The factors of 4 include 1, 2, 4. They have more than 2 factors here. Members here or the elements here are more than, because elements are the same as the members or a group of people in a set or a group of numbers in a set. So factors of 4 here, 1, 2, and 4. So this 4 can never be a prime number because it has more than 2 factors. Okay, so the number 4 is a composite number. Okay, Composite number because it has more than two factors. Okay, good. So 4 is not a prime number. Let's see factors of 5. 5 here, 1 and 5, which means that it has only two factors. Okay, 1 and 2. Okay, it has only two factors, and a factors in the 1 and except 5. Okay, so based on this, 5 is also a prime number. Factors of 6. We have 1, 2, 3, and 6 here. Then there are more than two factors. There are more than two. So this 6 here can never be a prime number. Won't mean friend a prime number because the factors near more than what? 2. So 1, 2, 3, 4. It has 4 factors. So this 6 is a composite number because it has more than two factors. Composite numbers are numbers with more than two factors, while prime numbers are numbers with exactly or two factors. Okay, let's see the factors of 7. Factors of 7 here is 1 and 7. Okay, there are exactly 2 here, two pair. So these two factors determine whether this 7 here is a prime number or composite number. But because there are 2, it has only two factors. Therefore, 7 is a prime number. Okay, those numbers are the factors you penny prime numbers, and those numbers are the factors more than two so composite number. But 1 is not a prime number, 1 is not a composite number because 1, it has only one factor. Okay, good. Factors of 8. Let's see the factors. Those numbers that can divide 8 equal is 1, 2, 4, and 8. They are more than 2, so 8 can never be a prime number. So 8 is what? A composite number because it has more than two factors. Factors of 9. 9 2 here, it has more than two factors. Okay, so since 9 possess more than two factors, 9 can never be a prime number. 9 is a composite number. Let's see the factors of 10. The factors of 10, 1, 2, 5, and 10. These are the numbers that can divide 10 equally. Aside that, number BM will be, and it has a limitation here. Last and 10. It means also. So based on this one, because they are more than two factors, therefore 10 is a composite number. Let's see the factors of what? 11. 11, it has only two factors. Only two numbers that can divide 11. Aside 1 and 11, there's no way you can get a number that can divide 11 equally. So based on this one here, and based on these two definitions or two factors, 11 is a prime number. Then let's see the factors of 12. Factors of 12, it has 1, 2, 3, 4, 6, and 12. Then 12, it has more than two factors. And based on that, 12 can never be a prime number. And then because of the factors here are more than two, then 12 is what? A composite number. Okay, good. Then let me take those numbers that are prime here. Okay, good. So 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11 is a prime number. Okay, so if you want to know the prime number of the remaining number, then you find the factors of those numbers, and based on the factors, you will get to know the prime number. So per prime numbers that is less than 13, prime numbers that are less than 13, we have the 2, 3, 5, 7, 11. Okay, so these are the prime numbers from 1 to 12. No, prime numbers is shimwani. Okay, good. Well, let's say 1 to 12 are prime numbers is shimwani. Okay, good. So these are the prime numbers. So these are the prime numbers because these numbers are numbers with only 2 factors. Okay, good. Now let's see another way that we can also use to identify prime numbers. There is a Greek mathematician somewhere BC before Christ 230. This Greek mathematician uses to sieve those prime numbers from any counting number that you want. The name of this mathematician is Eratosthenes. Okay, the process is called Eratosthenes, but the name is Eratosthenes Edu Ej Mensa. He is my uncle, right? Okay, we can go and find out. Okay, he's a Greek mathematician about 230 BC. No, before Christ, not. Okay, so he uses the method that we can derive a prime numbers from a given stated counting numbers here. So the first procedure, near friend is Sonny here. So we see who be so oh Sonny be so no, okay. So the process is called Eratosthenes. Okay. We say why a manko on tiasia or wanko nibusan. So me boa. So you can make a counting number table up to your own expectation. Counting number table here means me and let's say 1 to any number. So per count prime numbers less than 30. Let's say 1 to 30. Per prime numbers less than 50. Let's say 1 to 50. Per prime numbers less than 100. Yeah, you have to list a counting number 1 to 100. Okay. So when you list those numbers up to your expectation or up to your number that you'll be expecting, then first thing you have to do is that you cancel one. We will do practical one, so don't worry, okay? The only thing you have to know here is okay. So you cancel one. Why? Because one is not a composite number nor a prime number. And per our calculation that we did before here, we're able to identify that one can never be a prime number, one can never be a composite number, because based on the factors listed over there, it has only one factor, okay? And the prime numbers are numbers with 2 factors, 2 per, okay? And normally a 1 and a number now. But the composite number also here are numbers with more than 2 factors. Okay, there are more than 2 factors. Good. So the first thing you have to do is that you cancel one from your listed numbers. Now let's say per prime numbers less than 10. No, let's say 1 to 10. It was a cancel one. When you cancel one, then you circle the next number, and assuming say let's say 1 to 10. Cancel one, and the next number is 2. Okay, so you circle the next number, that is 2, and then you cancel all the multiples of 2 from the table. So what circle 2 no? Now I cancel all the multiples of 2 from the table. Then you circle the next number that is not cancelled, and that is 3. So you could see said number will cancel, and you cancel all the multiples of what? 2. So you circle the next number, and the next number is 3. Okay, from the 2 is 3, but 3 is not a multiples of 2, so you can also cancel the 3. So the 3 will be there. So you circle the next number, that is 3, and then you cancel all the multiples of the number that you have circled, which is 3. Okay, so we'll circle the next number, then you cancel all the multiples of that, and then you circle the next number that is not cancelled, and that is 4, because 4, it has been cancelled based on the multiples of 2 now cancelled. Then you cancel all the multiples of the number you have circled, and that is 5. Then you circle the next number that is not cancelled, that is 7, and then you cancel all the multiples of 7. Repeat the procedure by circling the next number that is not cancelled, and then you cancel all the multiples of it. Okay, the numbers that you have circled, they are the prime what? Numbers. Okay, so you are going to do the practical aspect of this one, but the person who invent this formula here, or the procedure to see or to derive prime numbers from the given numbers, his name is Eratosthenes. Okay, he is my uncle. Okay, good. So if you want to find the prime numbers, you list 1 to your expectation, 1 to 10, 1 to 50 prime numbers. This method can also help you to identify the prime numbers. Are you okay? Good. Let's go back and work practically to see whether you have really understood this procedure. Now, finding the prime numbers by using Eratosthenes sieve. Example, your prime numbers are less than 30. Your prime numbers, we want all the prime numbers that is within, okay, or between 1 and 30. Or we are going to derive all the prime numbers from 1 to 30. If you want all the prime numbers from 1 to 50, you have to list 1 to 50. If you want to derive a prime number from 1 to 60, you have to list 1 to 60. If you want to get all the prime numbers from this one, or 1 to 1000, you have to list 1 to 1000. Okay, but you, per your level, you're supposed to know the prime numbers that is from 1 to 30. Okay, it's not bad. You'll be learning more of these. Then let's see, because we want the prime numbers from 1 to 30, then you have to list 1 to 30. These are the counting number table that I was talking about. So that is the counting number table. You list 1 to 30. I've done my own here. Eratosthenes is saying, was it when you list 1 to 30, first thing you have to do is that just cancel 1. Why? Because 1 is not a prime number. 1 is not what? A composite number. Okay? Remember, say, so no, you're finding the factors of 1. We're able to get what? Only one factor, because 1 can never be a prime number. 1 can never be a composite number. Prime numbers are numbers with exactly 2 factors, while composite numbers are numbers with more than 2 factors. But here, we are able to sampa truly and answer and yet true. Okay, so you use the definition to identify. What's it? List or cancel 1, and then you circle the next number. Okay, so you circle the next number, and the next number here is 2. Okay, then when you circle the next number, which is 2, then you cancel all the multiples of the number that you have circled. Again, Was it so cancel one? You circle the next number, and the next number here from the one here is 2. And was here circle 2, you cancel all the multiples of 2. So 2 times 2 will give you what? 4. So 4 is a multiples of 2. You are going to cancel all the multiples of 2, okay? 10 is a multiples of 2. 12 is a multiples of 2. 14 is a multiples of 2. 16 is a multiples of 2. Yeah, cancel all the multiples of 2 from the listed numbers here. 18 ka ho, 20 so ka ho, 22 so ka ho, 24 also a multiples of 2. 26 also a multiples of 2. 28 so a multiples of 2. Then 30 is also a multiples of 2. So also cancel the other numbers here. Remember I said me say oh yeah there. Baby a wopɛ prime numbers na kusi ne saa number na abɛ list ya kusi. Mepɛ prime numbers less than 30 until my list 1 to 30. So we can take the prime numbers from the numbers 1 to 30. Okay. So we are still on the process. First one said cancel 1 because 1 is not a prime number or a composite number. After cancel 1, then you circle the next number. The next number from 1 here is 2. Then you have circled the next number, which is 2. Then when you circle the 2, then you cancel all the multiples of the number that you have circled, which is the 2. So you have cancel all the multiples of what? 2. And you are cancel. Then you circle the next number that is not cancelled. So from 2, which number is not cancelled? The next number that is not cancelled here is 3. Okay. Okay. Good. Then after circling the next number that is not cancelled here, which is the 3, then you cancel all the multiples of 3. 6 is a multiples of 3, but we have cancelled, so there's no need to cancel again. Okay. 7 is not a multiples of 3. 9, you cancel. No about 11, then you multiples of 3. 15, then you cancel. Okay. Then no about 19 is not. 21 is a multiples of 3. You cancel. 23, you multiples of 3, sister. Okay. 27 is also a multiples of 3. Okay. Good. Then 29 is not a multiples of 3. Then we have finished cancel all the multiples of 3. Then when you finish cancel the multiples of 3 or you finish cancel the multiples of the number that you have circled, then you circle the next number that is not cancelled. The next number that is not cancelled here is 5 because 4 is the next number, but 4 it has been cancelled. Or say circle the next number that is not cancelled. That is 5. Then you cancel all the multiples of 5 from the listed number here. So all the multiples of 5, 10 is a multiples of 5, but it has been cancelled, so don't waste time. Then you come you could see say 15 is also a multiples of 5, but it has been cancelled. 20, it has been cancelled. 25 is a multiples of 5, but it's not cancelled. Then you cancel. Okay, good. Now we have finished cancel all the multiples of 5. Then you circle the next number that is not cancelled. Okay, you circle the next number that is not cancelled, and that is what? 7. Because 6 is the next number, but it has been cancelled. So you circle the next number that is not cancelled, and that is 7. Then you cancel all the multiples of 7 here. 14 is a multiples of 7, but it has been cancelled. So 21, 2, it has been cancelled. Then let us assume we have finished cancel all the multiples of what? 7. Okay. Then you circle the next number that is not cancelled. The next number from 7 that is not cancelled is 11. 8 is the next number, it has been cancelled. 9 is the another immediate number, it has been cancelled. 10, next immediate, it has been cancelled. But the next number from the 7 that is not cancelled here is 11. Okay? Then you cancel all the multiples of 11 here. So 22 is a multiples of 11, it has been cancelled. Then you go. Okay? Let's assume it has been cancelled already, so there's no need to cancel. Then you circle the next number that is not cancelled. So from the 11, the next number that is not cancelled is 13, because 12 is the next number, but it has been cancelled. So we circle the next number that is not cancelled. So let's cancel the multiples of what? 13. 26, it has been cancelled already here. So then we have finished cancel all the multiples of 13. So from the 13, you circle the next number that is not cancelled. And then from 13, 16, 14, 15, 16, they are all next numbers to 13, but they have been cancelled. But the only next number or immediate one that is not cancelled is 17. Okay, good. Then you, once you have circled 17, you cancel all the multiples of 17, and I hope all the multiples of 17 here has been cancelled. Okay, then you circle the next number that is not cancelled, and that is what? 19. And then you cancel all the multiples of 19, and hopefully they have been cancelled here. And now here you circle the next number that is not cancelled. So the next number to 19 that is not cancelled here is 23 here, because 20 is the next number, but it has been cancelled. 21 is another immediate number, it has been cancelled. 22, it has been cancelled, but only 23 was not cancelled. So you cancel all the multiples of 23 here, and all the multiples of 23 has been cancelled from the list, and then you circle the next number that is not cancelled, and that is 29. Okay, then you cancel all the multiples of 29. Again, Eritasne say you list 1 to 30 or 1 to any number that you want based on the prime number that you'll be expecting from that. So after listing the numbers 1 to your expectation, then you cancel 1 from the what? From the number, because you first cancel 1. 1 is not a prime number, 1 is not a composite number. So when you finish cancel 1, then you circle the next number that is not cancelled, which is 2. Then when you finish circle 2, then you cancel all the multiples of 2. That is why you're able to cancel 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. The multiples of 2 women are no. Okay, then when you finish cancel all the multiples of 2, then you circle the next number that is not cancelled. It is very necessary. The next number that is not cancelled. So here from the 2, the next number that is not cancelled was 3. And then you circle 3. Then you cancel all the multiples of what? 3. Some of the multiples of 3 has been already been cancelled, so there's no need, because 6 is a multiple, but it has been cancelled by the multiples of 2. 12, 2, it has, so you waste. You don't waste more time. Then you cancel the remaining multiples of 3, and that's 15, 21, and co. Then you circle the next number. Once you have finished cancel all the multiples of 3, you circle the next number that is not cancelled. And the next number to 3 is 4, but that is not cancelled is what? 5, because though 4 is the next number, but it has been cancelled, but the only number that is not cancelled here is 5. So you circle 5, you cancel all the multiples of 5, then you circle the next number that is not cancelled, and that is 7. Then you cancel all the multiples of 7, and then you circle the next number that is not cancelled, and that is 11. then you cancel all the multiples of 11, and then you circle the next number that is not cancelled, that is 13 here, and then you cancel all the multiples of 13, and then you circle the next number that is not cancelled, and that is what, 17. You cancel all the multiples of what, 17, and then you circle the next number that is not cancelled, and that is what, 19, and then you cancel all the multiples of what, 19, and then you circle the next number that is not cancelled, and that is 23 here. You cancel all the multiples of what, 23 from the listed number here, and then you circle the next number that is not cancelled, and that is what, 29. So based on a returning sieve and the procedure, those numbers that we have circled, they are the what? The prime numbers. So the prime numbers less than 30 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Okay, good. So these are the prime numbers less than 30. Okay, good. So Eritasness, the process, the numbers that we have circled here, they are the prime numbers. And also, when you find the factors of 2, it has only 2 factors. Factors of 3, it has only 2 factors. We have done it already, okay? So aside using the factors to determine the prime numbers, you can also use a returning sieve to also derive prime numbers from the listed numbers here. Also, factors, we say prime numbers are numbers with only 2 factors. When you talk about the factors, we are referring to the number that can divide a given number equally. So when we take 2, only 2 numbers can divide 2 equally, 1 and 2. When you take 3, 1 and 3, 5, 1 and 5, 7, 1 and 7, 11, 1 and 11. 13, 1 and 13 can only divide 13 equally. 17, 1 and 17. 19, 1 and 19. 23, 1 and 23. 29, 1 and 29. Okay, so these are the numbers a bit may divided what a given number equal, and these numbers listed here are prime numbers. The remaining, exception of 1, are composite numbers because they have more than 2 factors. Okay, good. Now let's see the prime factors. Once you know your factors and you know your prime numbers, when you find the factors of given numbers, those prime numbers in the factors are called prime factor. The name is prime factors. So let's assume that we have an example here. Example. Okay, good. Say find the prime factor of 8, or what are the prime factors of 8 or prime factor of 8? Prime and a factor. Okay, so the first thing is that you find the factors of 8. Factors of 8. Of 8. Good. Numbers that can divide 8 equally: 1 can divide 2, 4, and then 8 is we have done. Okay. Oh yeah, use method, you know. So when you have your factors of 8, so within the factors of 8, which of them is a prime number here. Okay, then you check. Factors of 8, we have 1, 2, 4, and 8. So the only prime number in the factors of 8 is 2. Okay, so now you know, so 2 and 1 a number with only 2 factors. So 1 is not a prime number, so therefore the prime factor of 8 here, prime factor of 8 is what? Is what? Is 2. Okay, is 2. Now let's find another, the prime factor of what? Prime factor of 12. Find the prime factor of 12. Okay, then first thing you have to do is that you list the what? The factors of 12. Factors of 12 include 1, 2, 3, 4, 6, and 12. Okay, then when you list the factors of 12, then within the factors of 12, you circle the prime numbers in the factors of 12. Okay, so here I'm going to circle the prime numbers in the factors. 1 is not a prime number, but 2 here is a prime number. 3 here is also a prime number. 4 is not, 6, 12, they are not. So the prime factors, prime factors of 12 is equal to 2 and 3. Okay, good. So that is the prime factors. Okay, so you are not going to waste much time. I'll get time and use the factor tree to derive the prime factors for you. Okay, so these are the basic. So the next lesson we will learn how to find the prime factors well using the factors tree to do that. So let's see, this concept here will help you. Prime factors means factors which are prime numbers. Okay, prime factors, factors which are prime numbers here. So that is why we have the prime factors of 8 is only 2. The prime factor of 12 is 2 and 3. You can also set your own question and then you answer. You find the factors of the numbers and then you choose the prime numbers from that. When you choose the prime numbers from the factors, therefore, those answers that you choose is called prime factors because they are the prime numbers from the factors. Okay, good. Hope to see you again. Bye.